Hi, everybody, and welcome to CFE Media and Technology's virtual training week. For this session, time-sensitive networking, a game-changing industrial technology, we'll be joined by Thomas Burke, Global Strategic Advisor for the CC Link Partner Association. I'm your moderator, Gary Cohen, and I'm happy to be with you on behalf of CFE Media and Technology. CFE Media has met the standards and requirements of the Registered Continuing Education Program. Credit earned on completion of this program will be reported to RCEP at rcep.net. A certificate of completion will be issued to each participant. As such, it does not include content that may be deemed or construed to be an approval or endorsement by RCEP. Little overview of what we're going to be talking about today. Time-sensitive networking, or TSN, is a game-changing technology that enables multiple industrial Ethernet protocols and commercial Ethernet to coexist on the same physical wire, sharing the bandwidth of a commercial off-the-shelf Ethernet cable. The industrial Ethernet is the foundation for factories and process control applications to communicate seamlessly, allowing disparate devices and networks to be connected together. Data and information is a very important part of the digital transformation. Without the industrial Ethernet, you could not read or write data that you need from your control system devices and applications. This session is all about the industrial Ethernet and how you can leverage the TSN for your data acquisition needs. Our learning objectives for today: suppliers and end users will benefit from a deeper understanding of the world of connectivity as a competitive advantage and how the industrial Ethernet and TSN is the foundation of your smart factory. How to maximize productivity and reduce cost with intelligent smart factory solution-based architecture, realizing performance intelligence and connectivity in your industrial automation environment, and why Mitsubishi Electric Automation is committed to open standards, and specifically CC Link, i.e. TSN. Few comments about your attendee experience, just so you can get the most out of this session. Additional resources can be viewed and downloaded on the left-hand side of your screen below the session's agenda. If you'd like to take notes within the session, just click on the left panel labeled Notes to do so. Please remember this session will be made live at 10 a.m. Central or 11 p.m. Eastern. The question and answer session with industry experts starts at approximately 10:45 a.m. or 11:45 a.m. Eastern, or immediately after this presentation ends. If it runs a little longer than 45 minutes, the answers will be archived with this session. You can see the Q&A details in the Meetings tab on the left-hand side of your screen. Zoom invite details can be found in the Additional Resources tab under Q&A session. If you want to take this session again, not a problem. It will be available on demand. And if you're experiencing difficulties, please log out and back into the session to continue. Attendees are eligible for 1 PDH credit for this event airing on October 21st, 2022. It's categorized within the Technical, Health, and Safety, including Core Technical category for RCEP. This event is a live educational session presented on October 21st, 2022, and on demand afterward. Now, before I introduce today's presenter, here's a quick video from our sponsor, Mitsubishi.
TSN, which stands for time-sensitive networking, is truly a game-changing technology for really moving data from factory floor devices into the industrial Ethernet through IoT devices and pushing that data into the cloud.
All right, now we're through the business and we get to the fun part where I get to introduce our presenter, Thomas Burke. Thomas J. Burke is a global strategic advisor for the CC Link Partner Association, whose aim is to collaborate on industrial network connectivity worldwide. In addition, Tom serves as Global Director of Industry Standards for Mitsubishi Electric to lead strategic development and adoption of networking standards, including the adoption of Mitsubishi Electric's Open Network solution. He's also the Global Director of Industry Partnerships for Iconics, providing leadership to increase market share of Iconics' leading-edge product portfolio. His background includes being the former OPC Foundation President and Executive Director and pioneering the OPC Unified Architecture as a foundation of information integration and interoperability. He has a bachelor's degree in theoretical mathematics from John Carroll University and a master's degree in computer engineering from the University of Dayton. Tom, thank you so much for being with us today. And now you get to take over. I'll turn things over to you.
Thank you, Gary, for a great introduction. It's really a pleasure to be part of this training event and the importance of talking about, time-sensitive networking into our automation systems. It's just a great opportunity. And as you said earlier, time-sensitive networking, TSN, is really a game-changing technology. One of the things I want to just talk about, though, is I want to bring up one of my friends from the ARC Advisor Group, Craig Resnick, and he always looks at the key technology trends. And from his perspective, his top things have always been the digital transformation and basically the whole concept of how do you move data from all these disparate devices and networks and essentially get this from the OT world into the IT world. So the key technology trend that, basically all the manufacturing and all the process control industry is looking at is how do we complete and how do we work on our digital transformation journey? So what I'd like to introduce about the digital transformation journey is this whole concept of what I call smart manufacturing. And this is a common term that's used across the industry, but smart manufacturing from a Mitsubishi perspective is basically a partnership with a number of companies. And these companies basically all partner together essentially to help round out a complete portfolio and solution for your digital transformation. The partnership that we talk about is called the E-Factor Alliance, but the concept is really about taking data from the shop floor and moving it to the top floor in a smart environment through partnering with a lot of different companies. So I take all these different devices on the factory floor, and then what I'm able to do is I take that data from all those devices and convert it at the edge into useful information, and then I'm able to push that data up into the higher level cloud-based application. So if you think about the digital transformation, it's about connecting everything. I mean, we've been working from an IEEE standard. I was involved in OPC since the beginning of time. And I looked at the TSN technology about 6 years ago, and they were talking about audiovisual and they were talking about inside the automobile. And I recognized that we should be using this for industrial automation. And that was the first innovation that I said made sense for industrial automation for OPC. And in 2018, the CC Link organization actually incorporated it into their portfolio and added it. And now we have CC Link IETSN that I'm going to talk about. So what's the value of this TSN? I mean, from an end user perspective, they shouldn't care. But the reality is they need to care. Because in our current situation, the reality is you run multiple and different industrial Ethernets. I'm doing both application configuration and control. But what happens is I have to run it all on separate physical wires. And this is a challenge in most manufacturing installation. They've got multiple vendors, then they got multiple networks, and essentially it's very difficult to configure and maintain. With the TSN technology, it basically allows all of those industrial Ethernet protocols to run on a single wire. And that advantage is unbelievable because what happens is it lowers the cost. It allows you to run on commercial off-the-shelf Ethernet. And I can run all these different protocols and basically do control and also do configuration and do, other applications on the same physical wire. And that is a very good, use of the TSN technology that really talks about the digital transformation, the concept of, essentially OT to IT convergence. So, there's been a lot of global trends in adopting the TSN technology. I mean, from a government perspective, and we think about Industry 4.0, and we think about the Industrial Internet Consortium, all of these organizations have been working together essentially to how do we do the best technology and how do we take these industry standards and really allow and provide a mechanism that really supports the digital transformation. So, my engagement with OPC, with Profinet, with ODVA, Circos, and CLPA, along with the Avenue organization, really brings together all the TSN technology. So when I talk about all of them running on the same physical wire, all the industrial Ethernet organizations are very committed to this. So in April of this year, we announced something called the Industrial Automation Conformance Collaboration. And essentially, this was about these different organizations working together for the purpose of realizing the fact that TSN is a very important technology, and how do we make sure that we make this thing works across all of the industrial organization. So essentially, these guys are all working closely together to develop a conformance test plan for the IEC 60802 specification of TSN, and this will allow even greater compatibility across the phone. So if you think about what I'm talking about, you take a look at all these different devices that are out there. And the beauty is I've got a lot of different devices, and some of these are legacy devices and some of them are new devices. But with the technology that we're talking about with TSN and the different bridges and gateways you can put into the system, it's going to allow a complete environment to really allow this whole notion of taking all these devices, gathering data from devices I never dreamed of before, hooking up all my legacy systems from the past, and essentially being able to take that data and leverage all these edge computing systems outside of the manufacturing system and turn it into information and push it into the cloud-based application. This is the power that we're going to be able to realize with the TSN technology. And as I said, CC-Link, they were one of the first ones that actually developed and supported the TSN technology as part of the portfolio. But again, it's a solution. So this is what the digital factory is all about. It's about taking all these different digital components and tying them together and really bringing forward ability to gather data, turn it into information, leveraging all the industry standards like OPC and all the OPC UA companion specifications, and do this comprehensive modeling to share all this information such that everybody understands it the same way. Later on, I'm going to talk about semantics and syntax, but the beauty is, I can pick up the telephone and I can talk, and I don't care if the person's talking Japanese or they're talking German, we're going to be able to understand each other. And that's the power of what we're doing with the TSN technology. So a lot of people ask, well, so how do we get started on this stuff? I mean, it sounds wonderful, Tom, but what do we do? Well, there's a lot of things you do from a development perspective, and we're working with the suppliers basically to help them identify the devices, right? What those devices are, how should they work, what is the class of development they should be using, right? How should they develop this stuff? What is the methodology? And then essentially, how do they do the development? It's not complicated. Basically, what we're finding is the vendors, there's a lot of different tools out there that really helps people quickly bring TSN products into the market. So with TSN, it's both a hardware and software implementation. There's a lot of different partners basically that build solutions to really help people adopt the technology. This is a set of vendors down here that are basically building CC-Link IE TSN development tools to help people quickly bring products to market. What I learned in my OPC days is you had to have an open source. You had to have partners that enable people to quickly bring products to market supporting the technology. So you don't have to read the TSN specification. You don't have to read the CLPA specification. You basically partner with one of these companies and use their tools to quickly bring products to market. I have to talk about the evolution and where we are, and you take a look at, all the different capabilities. And this is kind of like an eye chart, but essentially, there's a lot of different capabilities. And this shows essentially the ability, Gary, to take the different technologies and be able to take legacy systems that are running, something called field basic or field, and partner and essentially be able to leverage and support the TSN technology. So there's just a lot of things in this fashion, but the common thing across the board is the cables are all the same, independent of the technology. So this essentially should just work all together in a seamless fashion. One of the big things people are looking for is plug and play. And what they really want to do is they want to take a device, plug it in my network, and have this thing work. One of the really cool things of TSN is that I can run control and I can plug a new device into the network without affecting the control algorithms that are running. And that's a powerful thing for manufacturing. This is a sample list of some of the companies that are already supporting the CC-Link technology. All these companies basically are embracing the TSN technology as well, and the list goes on. So when I look at this from an industry perspective of who's using CC Link and why CC Link's important, I mean, it goes across all the different, industries, right? It's not limited to automotive or semiconductor. The big thing now with all the lithium batteries and, essentially all the electric vehicles, this is all capability that can be easily leveraged in, manufacturing and in process like in water treatment or in oil and gas. Okay. Essentially, these are all, organizations and industries working together with the technology to really bridge the gap and, essentially move all this data and information and turn it into useful information that I can use. I'm going to talk a little bit about eFactory and the eFactory Alliance for a reason. With Industry 4.0, it's all about smart factories. It's all about the digital transformation. And I don't care, what organization it is. It could be Sesame, it could be the robot industry, it could be, platform industry 4.0, the Korean standards, but it's all about the smart factory. So in 2003, Mitsubishi introduced what was known as eFactory. And essentially, it's all about, an approach to the digital transformation that really affects business. And this is a big opportunity for us to essentially help our customers really develop a comprehensive business approach and essentially leverage all this, industrial automation and information technology through partnerships and alliances. So we've got a lot of videos and things that are out there. I'm not going to run the videos today. We've built almost 200 videos that you can, watch, but it talks about Industry 4.0. It talks about connecting everything. And there are a lot of great video content and thought leaderships. So if you think about what I just said, the eFactory concept is about utilizing factory automation and IT technology, reducing the total cost of development, production and maintenance. The eFactory Alliance basically takes all these different companies and working together, whether it's, software vendors, device vendors, system integrators, who are strong in their respective disciplines and really bringing, opportunities for even better integration and interoperability for the end users. So, I showed you this slide before, but the concept is simple. It's the eFactory Alliance. It's part of our eFactory umbrella, and it brings it all together. So let's talk about global strategic cooperations and what's important about this. So I speak about collaboration all the time, Gary, and the importance of collaboration really is leveraging all these software and IT systems, all the different industrial components, and the whole concept of system integration and leveraging all the different production systems and the robotics and basically tying them all together. And that's the important part of what, we're trying to do with a smart factory. So, Mitsubishi recognizes that they don't do it all. They don't have all the products. We need other partners basically to be part of our ecosystem. So we partner with a lot of other companies under the eFactory Alliance, essentially to bring, best of breed solutions to our customers. So when you tie it all together, you've got a complete ecosystem that basically is there. Now I'm going to talk about CC Link IETSN and what we're doing and why, and how it relates to the eFactory. So the big thing everyone recognizes is I need a network. I need a network, and I need a network that basically allows me to run multiple networks independent of who the companies are. So, I don't care if it's Mitsubishi, Siemens, Rockwell, Beckhoff. They all have their own industrial networks, but now we need a strategy that really allows us to maximize productivity and reduce costs with an intelligent smart factory solution. The TSN technology and what we're doing with CC Link IETSN provides that enabling technology to connect up all those devices and allow all these different networks to run at the same time on the same physical wire. And there's a significant advantage that allows us to connect up our OT world to our IT world. So, when I talk about this, I take a look at a lot of the different Mitsubishi products and things that come together and the focus at that. But a smart factory, if I think about what it means increased productivity, it means flexibility, it means maintenance, and most importantly, it means quality. So when you have, a TSN-based technology, what you have is data reliability. And basically that means that I can take data from two endpoints and I can guarantee that the data is going to get there and it's going to be reliable. You know, if you're watching a video, well, you're going to get a blip here and there, right? And you don't think about that. TSN was actually enabled and it was provided as a mechanism to stop blips in videos. It first was evolving as part of the audio visual industry. And that's when I recognized we should be using this for industrial automation. So, you know, there's a lot of different things that you have to take advantage of from a shop floor perspective, right? And you think about what goes on in the OT world and, you know, particularly like fast cycle times with high speed and high speed accuracy, right? And motion control application. You know, you got versatile IoT systems, you know, and the ability to be able to configure these things on the fly. Well, you know, so I think about the shop floor and then what happens at the edge level. It's got to take all that data and you want to integrate all that factory automation and IT stuff and tie it together so that it can take advantage of the big data analytics in the cloud and the connection essentially between the engineering and the supply chain. So that's what we really talk about. That's why it's about data. It's about information. It's about leveraging, you know, TSN and CC-Link IETSN and OPC-UA as a mechanism to tie all these things together in a uniform standard way. When I talk about, you know, what I talked about, what is time-sensitive networking? And, you know, it enables deterministic messaging on standard Ethernet, right? I mean, that's the big advantage of this. It's about convergence, right? It's got a standard time sharing method, which allows all the different, you know, industrial Ethernet organizations to work together. And that's a big advantage of that. So, you know, with CC-Link IETSN and why we chose the TSN technology, essentially because it supported TCP/IP communication and applies to any industrial architecture. So this whole concept really provides, you know, real-time data collection from the shop floor to the IT systems, you know, without any sophisticated, you know, nightmarish, you know, configuration. It truly is a plug and play architecture. So it's very flexible and allows, you know, the ability to, you know, quickly put a new device on the network and hook it up, and magically it just works. And, you know, without disrupting the existing control algorithms. And that's the important part of this thing and the high performance that it gives. So if I look at our family of different products and things like that, you know, whether it's an industrial personal computer, it's a machine, it's a line, it's a PLC, essentially all these networks come into play. So, you know, I frequently talk about SNMP and the ability to, you know, connect up to any type of device in the IT world. Well, this is a simple example of one of the things that you're going to be able to take advantage of. I'll be able to look at my hard disk and know if it's, you know, if it's getting, you know, filled, and I'll be able to do this as just part of the standard plug and play nature of the technology. So the first thing that we really talk about from a TSN perspective and this whole open integrated network is really about performance. And you think about, you know, utilizing, you know, AI, and you think about predictive maintenance, and I think about all the different ways that, you know, we want to make robots, you know, essentially adaptive and self-learning environments, right? Really, the TSN technology really provides a significant increase in the communication performance and enables really highly accurate motion control and high-speed I/O. And this is a very big thing, and allows these things without affecting operating performance of the applications and things that are going on as I'm moving information, you know, between different systems. So then I talk about intelligent. And the intelligent networks basically is all about realizing what I call easy device setup and preventative maintenance. And this is essential to efficient operations of any manufacturing, you know, installation. You know, we put together a lot of diagnostic software enabling troubleshooting of network devices because, you know, I am going to hook up devices that for some reason aren't going to work, but what can the, you know, the person do to figure it out quickly? So having, you know, extremely good diagnostics and, you know, generation of network system architectures is all part of the, you know, architecture of this open integrated network that really the combination of TSN and CC-Link IETSN bring together. Then I talk about connectivity, and the connectivity is really the key in realizing all this real-time communication, across the networks, right? It enables, other third-party networks and standard Ethernet devices like vision or sensors or wireless routers to be integrated. And so essentially I can do control and I can hook a vision camera to my system and not affect the operation of the OT world. That's a significant advantage of the technology. I look at the different performance capabilities and what we're talking about, and the numbers, basically show that, a greater speed of performance than we ever dreamed of before. I frequently speak of, the concept of, exception-based processing and the way the old IE field network worked. It worked basically, you passed a token around and essentially, well, now it's my turn to talk. Now it's my turn to talk. Well, with the TSN technology, it's done with something called time sharing. So it's all just automatically configured. And what happens is I get much higher performance because I'm not waiting to determine, is it my turn to talk now? Can I talk now? No, you can just talk on the network because it's all geared towards the time sharing capability of it overall. So I keep talking about, even mixing with TCP/IP communication. If you can do deterministic performance of all of this cyclic communication and maintain that at the same time with what I call slower information, okay, like, I'm printing a document off and I can have all these things on there. I can have my engineering software configuring things and doing things, and I cannot affect the load. It's perfect. So this particular diagram on the bottom really shows that, I got the blue line jumping up and down, but on the red line, it stays the same. So the value is that, with my control applications I'm running, everything stays the same. That's what 3 and 4 is. It's all just running seamlessly. 1 and 2, it can come and go, and it won't affect the performance of control. This is a big advantage of the TSN technology, and particularly what we're doing with CC Link. So, why do we talk about, these devices, and why do they require, you think about packaging machine, and you think about, different conveyors, and you think about all the control algorithm and the speeds that they're running. Everybody wants to produce more and more of their product. Well, the only way to do that is to really have extremely high speed communication. Low speed communication is great for devices that don't require high speed, but the beauty is I can run both of these on the same network cycle. And this is essentially the TSN technology. So, I can mix high speed devices along with medium speed, along with low speed. And essentially the TSN technology provides a mechanism for, juggling these things around to maximize productivity by really using what's called the optimum configuration cycles of the devices. So every time you plug a new device in, it's going to be recognized of what type of performance it needs, and it just magically works out of the box. There's a lot of applications that require synchronous control, particularly in areas like of servos and a lot of these other devices, and they can be connected to the same network at the same time, enabling synchronous motion control between servo motors and device station. This is a big opportunity, right? Because, I want to be able to have a vision camera out there and monitor these different things. And I need to be able to do high-speed synchronized communication between those different devices. So from a system perspective, I'm looking at, well, I'm going to do a bunch of application configuration. I'm going to do alignment adjustment. I'm going to do verification of the image. I'm going to do image analysis. But the thing is that the servo amplifier and the vision sensors working on the same network are not affected by the fact that I'm going to do some of this application level configuration and image processing. Significant advantage of the technology. I talk about the ability to do, an easier parameter setting. We use something called an imported device profile. It's well aligned with the OPC UA companion specification. You can import these profiles, and essentially it makes it easy for a system integrator, who has to set up all these systems to clone these different devices and essentially get all these different devices all set up. So there can be different settings per connected device, but it can be easily done in the same procedure when they're doing the configuration. There's a big opportunity for, again, make it easier and easier for people to, gather more data by being able to connect up devices in an easy fashion. And everybody wants plug and play. And the more we can do to allow, take an existing device and clone this through templates, all the better we are. So there's a lot of, things there that allow us a lot of troubleshooting, because, you're going to do things. You're going to end up, well, guess what? Simple problem of the cable got disconnected, right? Well, with the technology that we've put together, I've got a way to quickly find and visualize the network, right? And I can take a look at this thing and figure out exactly where the problem is, because there's significant diagnostic information that can be checked in real time. So I can determine a network error and I can fix this thing. I can find out what was the wiring change or change the module and quickly find this thing, which really, from the overall standpoint, this significantly reduces downtime. So the advantage of this is, if for some reason something goes wrong someplace, and it will, I can find the problem quickly without shutting my system down. When I talk to different customers about this, they jump up and down and say, "You got to be kidding me. You know how long it took us to find this last problem?" And there's the problem, right? You want to make it as simple as possible, so they can get their system back up and running and not have downtime. So, we do auto generation of all these network parameters. Again, it's, essentially it's easy. It's simply connected into the engineering software. We have a network master station, so they're automatically reflected. So as soon as I make a change, it gets reflected. And what this really provides is a whole mechanism to do, what I call, very consistent and very enabled, redundancy application. So, I can have an initial system configuration and then I can go modify it. And then what I can do is I can quickly deploy this, across my network. And that's a big advantage of this. So in this particular case, I'm adding a new servo, amplifier to the network. And what happened was it continued to run. Didn't affect anything at all, right? And we decided to remove, an inverter off the network at the same time. Well, the good news is the control continued to run at the same time, did not affect. I was able to remove one from the system configuration and add another one. So that's kind of the whole concept of what I call the auto generation of the network parameter. So again, I talk about easy diagnostics and data collection utilizing, generic Ethernet technology. People talk about, I talk about SNMP all the time. It can be used essentially for monitoring, general Ethernet devices. And with the software we provide, we embed SNMP in there as part of it. So it's free and basically gives you the capability to do a lot of really cool things, right? So I can take a look at my vision scanners, I can figure things out, I can take a look at my different devices, and I don't care what type of a device it is, in my TCP, networking structure. I got this capability that allows me to analyze and quickly diagnose a problem. That's what intelligence is all about. There's a lot of things where, I got highly precise time synchronization, right? And I need high speed accuracy all the time, right? And it all depends on, what I've been doing and, the different things that I've got. But the case is, because of the technology with TSN, I'm able to look at all these errors. So if you think of what I'm talking about, I'm able to take all these different, systems that have been out there before, all the different remote IO, and I can look at all these things and fine tune this and make it all run in a consistent fashion, which again, really leverages the determinism that's part of TSN. Safety's hot. And basically CC-Link IE-TSN and what we've done with the TSN technology enables control of both safety and non-safety communication really realizing what I call a total flexible system architecture. So it's easily able to incorporate it into whole main control network. So, there's a lot of different safety standards out there. And essentially that's very important when you think about drive control devices that are on the network, right? I've got the ability to have all my safety remote IO. So, people wonder, what are you talking about safety? Well, you understand the light curtain, you understand the emergency stop switch. This has got to be directly connected to the network. And with CC-Link IETSN, I can hook up that emergency stop switch through the safety remote IO, and I can stop things before something happens. Or I can have automatic stopping before, a problem occurs. So this is part of the thing where when you're doing any type of, sophisticated application, you've got to have safety communication built into the architecture. I talk about ensuring, latest functional version with firmware update. We provide basically the capability as, new versions come out. The firmware can be updated in all these different devices automatically, again, without affecting the performance or control of the network. We're still doing a lot of testing on that now, but really the plan is that with this firmware update tool, I shouldn't have to basically shut my network down as I'm updating the firmware. So this provides even better performance. When we talk about connectivity, I just talked about combining real-time control and TCP/IP. And the ability of this is, it's on standard Ethernet, it's utilizing TSN, it's got mixed communication. You can take a look at a lot of the different devices that are out there, right? And, it could be anything, right? But you take these different devices and, I can hook these things up and I can do different types of application. We leverage a lot of industry standards that are part of this. I'll talk a little bit about edge cross, but we're leveraging the OPC-UA standards and the OPC-UA companion specification to really take the data and understand the syntax and semantics of the data, like in the example I told you about. I can pick up the phone, I can talk, and no matter who I'm talking to, they're going to understand me. That's the beauty of what we're trying to do with the technology and how it all works from a connectivity standpoint. So we always talk, and the end users are hot on the whole concept of easy replacement of a lot of their remote devices. They want to have as short a setup time as possible. So you think about this thing and, essentially, there's a lot of different network parameters that are stored in what's known as the CPU module. Well, if I can automatically distribute that to all the remote devices while initializing the network, then I can take that, and then when the disconnected stations come back to the network, they just come up and running again. And that's the power of being able to do this. So I can replace a remote device. I can get all the, the parameters automatically downloaded from the master station to that new device without affecting the operation. So you've got limited downtime whatsoever. I've just swapped out a device on a live control network, and that new device automatically gets populated with all the parameters necessary for it to run. People look at me like, you got to be kidding me. How come we never had that before? So, but we do now. So, flexible system configuration, we can do multiple topologies, right? I don't care what the topology is, basically. I talk about line, topology where they're all linked, going down the line. I talk about a ring technology, which essentially goes around and round, and then the star technology, which, essentially goes through an Ethernet switch. So with CC-Link IETSN and with the TSN technology, we can support all these different permutations at the same time and still have, standard, reliable, high-speed communications without any difficulty. You want to be able to integrate a lot of other network devices into the equation. So what we've done is we've provided to make sure, I want everybody to use CC-Link IETSN, but that's not the world. The world is there's a lot of different industrial Ethernet networks out there like Ethernet IP. So imagine a world where I can just take my, my Mitsubishi program controller, my programmable controller, and I can talk to these different networks basically at the same time. And again, ultimately, it's going to be on the same physical wire, but essentially it's, I can add a new device that's Ethernet IP, and it's not going to affect CC-Link IE TSN control applications running. This is a big advantage to the end users. They're running on the same physical wire. I can take any compatible device from an Ethernet IP and I can plug it in on the wire. I can do the same thing with CC-Link IE TSN, and they're all going to run together in a seamless fashion. You know, the visualization of sensors and space saving, we talk about the AnyWire technology. There's a bridge module that integrates, essentially the AnyWire compatible sensors with CC-Link. So again, it's the same opportunity. I can take the settings and I can diagnose any of these compatible sensors, and it's easily done by just connecting up to our programmable controller via network. So, I can select a module in the system configuration. I can look at this thing, I can configure it, I can change the diagnostics, and I can troubleshoot the problem. It's highly scalable system using all these best-in-class devices, right? We support implementation of, like I said, high performance devices, essentially with, the dedicated FPGA or the ASIC, and low cost devices that are using a software protocol stack with a standard Ethernet chip. The stuff just works together. So I've got a combination of high performance and low cost, and I can mix these configurations together and really taking advantage of the performance of the CC-Link technology with TSN. So again, we look at this picture over here, it shows all these different areas, right? I got an area that's focused at, a lot of different devices in one category. I've got another area that's focused with some other devices. Then I've got a safety network. Then I've got a machine. But what I can do is with the TSN technology, I can connect all these different areas up together. And I'm able to gather data from all these different disparate devices and disparate networks, independent of the applications they're running. And then I can take that data and push it through an Ethernet switch, put it into some edge computing device in the manufacturing arena, and then push it up into, essentially over the same physical wire, so I can do intelligence analytic on the data and essentially allow, using the OPC UA technology or anything else, essentially being able to analyze this data and push it into the MES and the ERP world. So, I can't talk, I could talk forever on this topic, but again, it's flexible IoT system configuration. Everybody talks about, IIoT and how do they leverage it, right? And if I can mix both real-time and non-real-time, information on the same physical wire, we've done, a great thing. So the great thing is, putting a lot of these different applications out there, and it doesn't affect my real-time deterministic control communication. I can connect up all these things, and I've really got what the digital transformation is all about. It's about connection. It's about connectivity, right? I talked about increased productivity, as a thing. Summary is I talk about reduced startup, and the ability of, saving time from an engineering and a maintenance perspective, leveraging technologies like SMP to look at all these different devices in my network. There's a lot of different development methods basically available to support the different products. So, you can quickly bring products to market for the CC-Link IETS technology. So in kind of a summary, I look at a lot of the things that, Mitsubishi's done with, their different modules that support the CC-Link IETSN technology, whether it's masters or locals. They all recognize the beauty of, having real-time motional control applications with standard TCP/IP at the same time. So couple that with, the IETSN performance and functionality, we're able to maximize it. So, in summary, I'm able to mixing of control and TCP/IP communication, which the end users are all excited about. I can detect failures on the network and change things on the network easily because I've truly got automatic detection of what I call plug and play. I can do very flexible system configuration integrated with safety. I can do all kinds of different motion control application. And again, it's highly scalable motion control modules based on whatever the application need. And, a lot of the motion control software embedded in the, industrial personal computers all leverages and realizes, essentially TSN is their, compatible motion control system. So we look at these IPCs, and based on their application requirements with motion, we're able to contribute to essentially much higher degrees of system functionality. So if I remember anything at all, I want you to remember TSN, time-sensitive network, CC-Link IE-TSN uses TSN, and essentially it's the environment. It's the foundation for your digital transformation. You can now have all the different industrial Ethernets run on the same physical wire. I can do control and application configuration, and I can plug and unplug devices on the network without affecting control. With that, I thank you very much for your time. That's a kind of a quick summary overview of why I'm so excited about this TSN technology and all the things that we've done basically to help you successfully achieve your digital transformation journey. Now I'll turn it back over to Gary. Thank you very much.
Perfect. Thanks so much, Thomas, for that great presentation. Now we're going to move into the Q&A portion of the session that is originally taking place on October 21st at 10:45 a.m. Central or 11:45 a.m. Eastern. Questions will be answered in this live Q&A. To participate in this live Q&A with your Zoom invite details, these details can also be found in the Additional Resources tab on the left-hand side of your screen.